Let's discuss another example here. The first step is understanding the problem that we want to model. Okay, M&D Chemical produces two products that are sold as raw materials to companies manufacturing bath soaps and laundry detergents. One of the main points of this paragraph is the fact that the producer produces two products. We will use this data in our modeling. The first bullet says M&D's management specified that the combined production for product A and B must total at least 350 gallons. A customer ordered 125 gallons of product A. For this one, it gives you the minimum amount of production you must have, because already you have a customer who put the order of 125 gallons of product A. Product A requires 2 hours of processing time per gallon, very similar to the previous example that we had with the cutting and dyeing, with the finishing departments, that each product demands a specific amount of time or resources. The next one, it says product B requires 1 hour of processing time per gallon, and after that it says that you totally have 600 hours of processing time. M&D's objective to satisfy these requirements at a minimum total production cost. So it is talking about the objective function. The objective function is not maximizing anymore. It is minimizing the production cost. After that, it says production costs are $2 per gallon for product A and $3 per gallon for product B. Again, very similar to the previous one, but for the previous example, it talked about the profits per bag. Here it talks about the cost per gallon of each product. So it seems quite obvious. It's a manufacturing challenge here. We have some orders already, so we need to produce at least in a way to meet that demands. Also, we have some time requirements similar to the previous one, and also it talks about the cost. You should have no problem in that. And again, don't forget pausing the video. Don't check the answers. First, make sure you have put a generous amount of time on each challenge, on each question, on each slide before you check it, because there is no point in checking the answer. It is like checking the answer for a puzzle. All the educational purpose of this design would be ruined if you are not patient with that, because you are learning now. So on each page, pause it, read it several times, and make sure you are completely caught up. I told you the reason that I pass quickly is to make the video short and with the minimum size. Okay, like the previous one that we talked, first to make sure we have understood the problem, we need to answer these three questions that we are seeing here. Okay, the first question, what is their goal from applying decision science? The goal is minimizing the total cost. What do they expect from the model to tell them? They expect the model to tell them how many gallons of product A and how many gallons of product B should be produced to meet this goal, that is minimizing the total cost. And the last question is, what are their limitations in decision making? We noticed that there is limitation in production because we have some orders, so we need to meet that orders, and also we have time limitations. Let let's walk you through a trick to understand the model better. See, when you read the model, try to get the point or the reason of each single sentence in your problem. M&D Chemical produces two products, okay? These two products that you see here talks about, most probably about the decision variables, because you have two products that are sold as raw materials to companies manufacturing bath soaps and laundry detergents, okay? M&D management specified that the combined production for product A and B must total at least 350 gallons. What is this? When I'm asking you what is this, I'm asking you to say if it is objective function, or if it is constraint, or if it is related to decision variables. Here, as I told you, when you see such kind of referring to the problem, most probably it is decision variables. Here it says that you need to produce at least 350 gallons. Okay, so it is constraint because it says that you are not supposed to produce less than this amount. So it is constrained. After that, it says a customer ordered 125 gallons of product A. Again, it's constrained. Why? Because of already having a customer ordered 125 gallons of product A, you need produce at least 125 gallons. So again, it is constrained. Product A requires 2 hours of processing time. Product B requires 1 hour of processing time per gallon. And the total availability of time is 600 hours. It's very similar to the constraint that we have in the previous example that we discussed in the previous session. After that, it says the objective is to minimize the total production cost. So it is objective function, and it is some details about the objective function. So you see, every details you want, you need to do your mathematical modeling is available to you through good understanding of the scenario, the problem. Okay, let's continue to the next slide. What are the decision variables? The decision variables are two, A and B. We denote them with A and B. A is the production volume of product A in gallon. B is the production volume of product B in gallon. Why? Because in this decision variable definition, you see that they are controllable inputs. We can decide to produce 100 gallons of A and 200 gallons of B. And they are specified by decision maker. So it is decision making, and they are the final answers that we want to get from our model. The next part, our objective function. Some details that we need to define our objective function is production cost that are $2 per gallon for product A and $3 per gallon for product B. So when for each gallon of product A, we incurred by $2 of cost, the total cost for product A would be 2 times A, and for the B would be 3 times B. So the objective function would be this, minimizing 2 times A plus 3 times B. The next step, our constraint. The first constraint talks about the fact that the product of A and B must total at least 350 gallons. So the summation of A and B, that are the number of gallons of A and B, should be greater or equal than 350, as you can see in this slide. The next one, it says a customer ordered 125 gallons of product A. So the amount of production of product A that is denoted by A must be greater or equal than 125 gallon. It is the one. The logic is exactly similar to the example we did last session. And for this one, you should be very familiar with this constraint, because it is exactly the same as the constraint, time constraint that we had in the previous session. Product A requires 2 hours and product B requires 1 hour, and the total availability is 600. So 2 times A plus 1 times B should be equal or smaller than 600. The processing time constraint. There is no other constraint here. So now you're all ready to write down the full mathematical model. Here you see it talks about the non-negativity constraint. Last session I called it positivity constraints. Sometimes it is called positivity constraints. I didn't notice that I said that at the moment. And although it conveys the meaning, but non-negativity is better name and definition for that, because it's possible for a decision variable to be 0. So when we say positivity, maybe it convey only they can get positive numbers, although but they can get also 0. So instead of saying positivity constraints, let's say non-negativity constraints. Sometimes it's a typo if I just say positivity constraints. Try to call it non-negativity constraint, because it's quite acceptable that, for example, in the manufacturing plan or scheduling that you get, you say, for example, we want to produce 1,000 of product A, 1,000 gallons of product A, and 0 gallons of product B. It's acceptable. So it is the non-negativity constraint. It stops computer from generating negative number, because it would be nonsense to say, for example, produce -5 gallons of product B. Absolutely, the result must be non-negative. So the constraint is called non-negativity constraint. Okay, the full mathematical model, try to write it yourself and check the answer with the one that comes immediately next. Here you can see the full mathematical model of another example that we just did and discussed together. The first difference that you noticed between this problem and the previous one that we did is the fact that in the previous example it was maximizing problem, but here it is a minimizing problem. They are very the same. In the logics, absolutely, when it is about profits, you want to maximize it, but when it is about costs, you want to minimize it. So you minimize the total cost of the things, and after that, we get to the constraint. ST is initial for subject to the constraint. We discussed these 3 constraints that you see here. Constraint of demand for product A, that you need to at least produce this amount, the total production that must be at least 350, and after that the processing time, and finally the non-negativity constraints. Remember, in the mathematical modeling, since always everything gets more and more complicated, you need to be very good with the previous discussions. When you are good with the previous discussions, each session there is just trivial changes to the previous ones, so you will enjoy the learning process, and you would have no hard time in learning. So I recommend always keep caught up with the course and try to enjoy it. And if you have any question, quickly shoot your question toward me. I will post the announcement how to do it in a very orderly way to get your answers very quickly. Thank you so much.